Okay. Say hi.
Alright, so without writing the instructions, same instructions as the last week. Yeah. So we've got a function. So this will be one of the three for for the quiz tomorrow. It's two terms with a fraction in it. It'll be something like this, different numbers, kind of any one of the three. Those are the three videos we've got. We are going to be writing. I'm shutting the door. We're going to be writing the equation of the tangent line to the curve at time x equals 1. So the same, sorry I didn't write it, but it's the same instructions. I'm going to have to stick on this board. I have to use the expo because the board isn't working. So let's go ahead. Step 1. Step 1 is find the derivative. Step 2 is plug in the x value. Step 3 is write the equation of the line. So let's do step 1. Step 1 takes way longer than all of the other steps. Okay, so let's go through step 1. So let's do black since that's written in blue. So f prime of x, which is the limit as h approaches 0 of, and we'll plug it in because I don't need busy work. So we've got 3 times x plus h plus 2 over x plus h, use parentheses to show you what I've done, minus f of x, so we'll distribute the negative as we do it. So it's minus 3x and then minus 2 over x. And that is all over h. Now, from every limit problem we've done, we've got a situation where we need to flatten that fraction. It's going to be easier than yesterday because once we flatten that, we don't need to do the multiplying by the conjugate. So,
did you distribute like first and then cancel out 3? Like, so if you were to distribute,
sure, you just have to do it to more terms. Yeah, you could though, it'd be fine.
And before you flatten the fraction?
I wouldn't, but you can.
Okay.
Mm-hmm. Yeah.
Wait, why wouldn't you?
Because it's more terms, it's more work. I'm lazy. So.
Well, wouldn't you be getting rid of a term? Like you'd be getting rid of.
No, because you'd have 3x plus 3h, and then you'd have to multiply the least common multiple to both of those. Whereas you only have to multiply it to that right now. So let's write it in blue, make sure you can see what I'm doing. So I'm going to multiply by what will cancel out those denominators. So we need a factor of x plus h. That will cancel that out. And I need a factor of x to cancel out. Everything else is 1, we just don't write it. So then what that doeth to the top, that doeth to the bottom. Alright, so there we go. So let's horizontally move since I've got limited space here. So I am taking this, right? I want you to look up here. So I am taking this, everyone, I want to see because certain people I'm talking to, I want this term, these two factors get multiplied to every single term individually, right? And that's what you think about. So we've got the x plus, well, here, nothing cancels out to the first term. So I have, let's write everything out just the first time. I know you can probably do it in your head, but just to make sure no mistakes. We've got 3, the base squared, so that's x plus h squared, times x. Then, when I multiply the second term, I have 2. The x plus h cancels out, and I'm left with 2 times x. When I multiply the third term, nothing cancels out, so I have a negative 3 times x squared times x plus h. And I multiply this term, the x's cancel, leaving me negative 2. And like I said, you can probably do it, but I'm just going to leave it in the parentheses. So the x's cancel out. I have my negative 2 times my x plus h. That is all over my h times my x plus h times my x from down there. Then next step, next line. So let's just start cleaning it all up. So f prime of x is the limit as h approaches 0 of, let's see, let's be slow and meticulous. There's not a hurry, you can have plenty of time. Okay, let's just make sure we don't make any mistakes. So I'm gonna expand that binomial. I'm just gonna bring the others along for the ride. Just distribute that negative and everything else just come along for the ride, and we'll clean it up on the next sweep through. All right, so just go slow. So I've got my 3 times my x squared plus 2xh plus h squared. And then that's also got to be multiplied by the x when I sweep through next time. And then plus 2x and minus 3x squared. We'll distribute that one. So I have a minus 3 times x squared, minus 3x squared times x, which is minus 3x cubed. And then I have a negative 3x squared times an h. So I have a negative 3x squared h. And then I have a negative 2x and a negative 2h. All over h times x plus h times x. Trying to decide if I can squeeze it in horizontally. Even if I run off of the white, can you see it? Yeah. I'll go down one row. All right, so let's distribute the 3 and clean it up. I'm sorry about this. I'm indecisive. I'm gonna squeeze it in here. I'm gonna squeeze it in there because otherwise I'm gonna be down on my knee. So I've got 3x squared plus 6xh plus 3h squared, and then all of the x's go to that. So I'm gonna do that in one. So everything basically here is a power. It's a power x higher, isn't it? So that's really an x cubed. That's an x squared. And that's an x, and then I'm going to go to the 3's. So I have 3 x cubed. I have 6 x squared h. I have 3 h squared x plus 2x minus 3x cubed minus 3x squared h minus 2x minus 2h. I did it. All over. Of course, I didn't fit my limit notation in. All over h times x plus h times x. So now let's rewrite it. And then we'll cancel the h's, then we'll apply the limit. So I say those things, so in case you do listen to it again, so we're thinking ahead what we're doing, right? So I've got my 3x cubed and my minus 3x cubed. Won't write those. I've got to bring my 6x squared h, my 3h squared x, and my minus 3x squared h. I know those can combine. I'm just going to leave them there for one time just so you can see it. So I have my 3x cubed gone. My 6x squared h stays. My 3h squared x stays. My 2x and my negative 2x drop out. My x cubed's dropped out. I have a minus 3x squared h here. So I have a minus 3x squared h, which is nice because those will combine. I got rid of my 2x and I have a minus 2h. See, that shrunk up a lot, didn't it? Now, we'll go ahead and we'll cancel the h's out, and then we'll apply the limit. Okay, because we are basically, when it boils down to it, we are, for the entire section 1, we are removing this discontinuity. We are trying to analyze it algebraically with this discontinuity removed, and the only way we can remove discontinuity is canceling a factor. So we have to factor h out of all of these, right? And we'll do that. So now I'm going to apply the limit. I'm going to put an equal sign on it here in a second. So I'm going to be thinking, I'm going to, right here, my limit as h approaches 0. So if I divide an h, well, let's combine these. I've got 6x squared h minus 3x squared h. So I have 3x squared h's. Are you okay with me there?
Yeah.
And I'm going to cancel the h out. So I have 3x squared. Then I have a 3h squared x. So that's really a 3hx. And then I have a minus 2h, so that's now a minus 2. And that is over, we factored out the h, so this guy's gone. Now that's over x plus h times x. So let's apply the limit now. Because now we can apply the limit, because when I put 0 in for h, division by 0 is not happening. We're not seeing that part. We've removed that discontinuity. We actually, it's still there, still doesn't exist there, but it's now a limit. Come up to it. So plug it all in. So the limit equals 3x squared with h being 0 doesn't change a thing. 3hx when h is 0 is just 0. Minus 2, because that doesn't change. All over x plus 0 is x times x. So x times x is x squared. So the limit is truly gone here. I should have had like all of my limit notation, all of that. The limit is truly gone because I just applied the limit. Now, like if you get as far as that, and you can plug it in, but I'm going to clean it up for you. So I've got 3x squared over x squared, which is just 3, minus 2 over x squared. So I'm boxing it so that I can find it later, but that's not my answer to the problem, right? We did a lot of work, but make sure we go back and write the equation in the tangent line here in a second. How much time is it?
13.
13, okay, I can do it 18.
How do you have the 3x squared minus 2 over x squared to the 3 minus?
I divided that, right? There's two terms there, right? So in Algebra 1, you might see them doing this, because this is a monomial and a binomial, so you couldn't take each of them. So x squared over x squared cancels, so you got 3, and then negative 2.
So the 3 is then out of the fraction.
Correct. Yes, that fraction bar is no. Yes, that's 3 over 1. Mm-hmm. Yes. All right. Let's. If you have a question, mark it down, or mark it down, and we'll talk about it right afterwards. Okay. So, or I can stop the video and take it now. What do you want to do? I don't mind. Just. All right. All right, are we good on this? Because I have to erase it because I don't have my new piece of technology yet. But it's coming. We good?
Yep. I'm so excited.
Okay, I'm erasing. I hear you guys talking, you right? Okay. When I get my new piece of equipment, I have to find another way to work out, because how am I going to work my shoulders out if I'm not cleaning this board all the time? All right? So, all right. So, step 2 and 3, evaluate the slope at time 1, and then write the equation of the tangent line. So, step 2, f prime of 1 is, I forgot what it was what, 3 minus 2 over x squared?
Yeah.
Okay, so I've got 3 minus 2 is just 1. So the derivative at time 1 is 1. Step 3, write the equation of the line. Y equals mx plus b. So help me out, please. What's my y value on the curve? Wait, say it one more time. I did hear it, actually. I've plugged it into the f value. My m is my slope. Let's write it. No one usually writes that, but let's just write it so you make sure that you know where it is. So that's my m. That's the derivative 1. Times my x value, which happens to be 1 as well, which is added to my b value. 1 times 1 is 1. 1 plus b is 5, so b must be 4. So then once again, come up, write my equation, circle everything. So y is equal to 1, so y is equal to x plus 4. Done.